Hello! In this tutorial we will talk about Java Heap and Stack. Previously in the tutorial Objects Allocation inside the memory, we talked briefly about how objects and methods are allocated inside the memory. In this tutorial we will talk extensively and in more details about that point. In the tutorial Objects Allocation inside the memory, we mentioned that when you run an application, the JVM divides the memory into heap space and stack memory. Heap in Java is a space used for dynamic memory allocation for Java objects and GRE classes at the runtime. New objects are always created inside the heap space. Stack memory. Stack memory is the location in which the called methods and local variables are allocated. Local variables inside the methods are usually reference variables referring to allocated objects inside the heap. Allocated methods are accessed inside the stack in LIFO order. LIFO stands for last in, first out. That means that the last added item is the first removed item. To understand this point well, let's see a practical sample showing in details what are the changes occurred inside the memory step by step after each statement. In this sample, we have declared a class called car. Inside this class, we added an integer attribute named HP. HP means horsepower. And then we have declared a setter and getter method for the horsepower value of the car object. We have also added another class called main. In this class we added the main method and other two methods named swap1 and swap2. And we have added that piece of code inside the main method. And now let's trace memory status step by step after start executing this program until the end of this program. We have now started execution of the program. The first step occurred. The JVM has allocated the configured space of both heap space and stack memory inside the machine's RAM. And we will learn later in this section how can we do that. Okay, after allocating the heap and the stack, the main method has a parameter array of string called args. This parameter is holding a specific value. So the main method is added inside the stack and the object value of args is allocated inside the heap. Inside the main method in the stack, it allocated a slot holding a reference variable of type array of string. This reference variable is referring to the array of string object allocated inside the heap. Now let's execute the first line car C1 equal new car and see the status after executing that statement. As we notice inside the main, a new slot of type car is added. This slot is holding a reference variable named C1. Inside the heap, a new object of type car is added. This object contains a slot of type integer named HP and the value of HP is 0. In the next line, we have called the method setHP by the reference variable C1. SetHP method is accepting an integer parameter named HP and the passed value in this line is 200. When called the method, as we see, it is added to the stack at the top of the main method, and inside it, an integer slot named HP is allocated inside it, holding the value 200. After that, the method is executed and set 200 to the attribute value HP of the car object referenced by C1. After that, the execution of setHP is finished so that it is removed from the stack with all of its contents to let the stack contains only the main method. And now let's execute the next statement car C2 equal new car. As we notice, after executing that statement, a new object of type car is allocated inside the heap. This car object contains an integer slot named HP with initial value 0. And also another slot of type car named C2 is added in the main method inside the stack. This C2 is referring to the new added object inside the heap. And now when we execute the statement C2.setHP 300, the same thing occurred with C1.setHP will be repeated. SetHP method will be added inside the stack allocating an integer slot named HP holding the value 300, and after being executed, it will change the HP attribute of the car object referenced by C2 into 300. And after finishing executing of method setHP, it is removed from the stack with its contents. In the next line, we call the method swap1 and we pass to it the reference variables C1 and C2. Let's trace it now. When it is called, it is added to the stack at the top of the main method and allocates 2 slots of type char. Those slots are named A and B. When C1 is passed to the parameter A, the swap1 method's local variable A became referring to the same object referenced by the main method's local variable C1, and B became referring to the same object referenced by the main method's local variable C2. When we execute the line char C equal A, as we notice, there is a new slot of type char named C is added inside the swap1 method, and this variable C became referring to the same object referenced by both swap1 method's local variable A and the main method's local variable C1. After executing the statement A equal B, the swap1 local variable A will refer to the other char object which is referenced by local variable B, and after executing the statement B equal C, B became referring to the char object referenced by the variable C. And now, as we notice, we have swapped the variables A and B. The question is, does this swap affect the values of the passed arguments C1 and C2? The answer is no. C1 and C2 are still referring to their instantiated objects, so this swap1 method has swapped its parameters A and B but didn't swap its passed arguments C1 and C2. And now, after finishing the execution of swap1 method, it is removed from the stack with all of its contents. Okay, let's now call the method swap2. Let's trace it and see the status step by step. After being called, it is added to the stack at the top of the main method, allocating 2 slots of type char named A and B. A became referring to the char object referenced by the main local variable C1, and B became referring to the char object referenced by the main local variable C2. When execute the statement int hp1 equal a.getHP, a new integer slot named hp1 is added inside the swap2, and another method named getHP is added in the stack at the top of the swap2. After executing the method getHP, it returns the value of HP attribute of the char object referenced by variable A, and then assign this value inside the integer local variable hp1. After finishing execution of getHP, it is removed from the stack. In the next statement, int hp2 equal b.getHP, the same thing occurred with statement int hp1 equal a.getHP will also occur to this statement. A new integer slot named hp2 is added inside the swap2 method, and getHP method is added inside the stack at the top of swap2 method. After executing the getHP method, it returns the HP attribute value of the char object referenced by variable B, and after finishing executing the getHP method, it is removed from the stack. In the next line, the statement a.setHP is called, taking the value of HP variable as argument, and for sure the method setHP is added inside the stack at the top of swap2 method. It allocates an integer slot named HP holding the value of its passed argument, and when the setHP method is executed, the value of HP attribute of the char object referenced by A is changed from 200 to 300. And after finishing execution of setHP method, it is removed from the stack. And when called the next statement b.setHP, taking the value of hp1 as an argument, the setHP method is added to the stack allocating its local integer variable hp with value 200. And when the method is executed, it updates the hp attribute of the char object referenced by b from 300 to 200. And after finishing execution of the method setHP, it is removed from the stack. And now we have also finished the execution of the method swap2, so it will be removed from the stack, letting the stack containing only the main method. And now let's ask another question. Did the method swap2 swap the values referenced by C1 and C2? The answer is no again. As we notice, both reference variables C1 and C2 are still referencing the same objects that they have been instantiated from the beginning of this program. But the occurred change is swapping the values of HP attributes between the both char objects. Okay, there is still remaining statement to execute, C2 equal null. After executing this statement, the reference variable C2 is no longer referring to any object in the heap, and the car object which HP attribute value is 200 became without any variable referring to it, but it is still allocated inside the heap and waiting to be garbage collected to free its allocated space inside the heap. Finally, we have finished executing the program, so the main method is removed from the stack, and then the program is terminated, so its heap space and stack memory are removed from the machine's RAM. Okay, in this tutorial we talked about the Java heap and the Java stack. We learned them extensively. We learned what are their functionalities and learned how they are used. We performed a practical sample and observed the status of heap and stack step by step. That practical sample confirmed our knowledge about the heap and the stack. Thank you for watching. Bye bye.